All right. So this is where we left off, was looking at this beauty right here. The channel, Powell, it's Baconomics is my YouTube channel, Baconomics, just like it sounds, okay? Clever, yes, just like it sounds. I actually think I have it posted somewhere on your syllabus. That's gonna be it right there, okay? So we left off right here. We had taken all this data, right? Pretty straightforward data: quantity, marginal revenue, total cost, marginal cost, average cost, profit. We've taken all of this and we'd graphed it, because that's the way you're gonna see it, okay? Really showing it to you in the form of that chart is just so that you understand that this is just simple data that we've plotted, created curves, things like that, in order to sort of create a visual that we can very clearly then identify the data that we're looking for and that we need, okay? And so we talked about this top graph, total revenue and total cost curves, that we needed to create two separate graphs. One graph for totals, and then one graph for like per unit numbers, marginals, averages, etc. This bottom graph being 100 times more important than the top one. We don't do this much. This is just two curves. You know, there's just not a lot to be said or found there. There's a whole lot more data down in here, okay? And as we build, you're gonna see all the different things that we can do with it, okay? But you can see here, we have total revenue, that's the yellow one, total cost, that's the red. I would definitely give you a multiple choice question on this one that just said, what's fixed cost? I hope you'd be able to tell me the answer. Can anybody tell me the answer? By looking at this, can you tell me what fixed cost is? What is total cost when the quantity produced is 0? 15, thanks Dennis. It's 15, right? I might give you this big graph full of all kinds of data and ask you something as simple as that, because you should be able to recognize that by now, okay? But we find our profit maximizing level of production when we find the greatest vertical distance between total cost and total revenue, where total cost dips below total revenue. This is the portion of the graph. These are the quantities in which we see profit from here until here, where it turns back to negative again, okay? So I found the greatest vertical distance at 12 units, where total cost is 48 and total revenue is 60, and the difference, which is my profit, revenue minus cost, is my $12 in profit, right? We already know that, because we already looked at this. 60 total revenue, 48 total cost, the difference is 12. That's my greatest profit. Happens right there at 12 units, okay? And then we went down here and we looked at our per unit numbers. Well, you know a marginal cost curve, right? It's this yellow check mark here. You know an ATC, it's this U-shaped red line right here. You calculated it, you graphed it on your last worksheet. All that busy work I gave you, it was really to get you thinking about this moment, this graph right here. And the thing that I've added for you, I didn't put my AVC on here. We'll add that on in a few more slides. I just didn't need it here. It wasn't important for the analysis, but you'll see when it is important for an analysis. But what I've put on here for you is this blue line right here, which is your demand, your firm demand curve. Your market determined that $5 was the equilibrium price for a bushel of wheat. You were a price taker, you had to take that price. And then we graphed that perfectly horizontal, perfectly elastic demand curve right here at $5. Well, in the case of perfect competition, your demand curve is also equal to your marginal revenue curve or line and your average revenue curve or line. Those are actually, all three of those are sort of stacked on top of each other here. They're all the same. And if we went back to marginal revenue, right, column 2, we would see that. No matter what the quantity is, our marginal revenue was 5. It's not like that in every market structure. This market structure is the simplest. This is where you learn how to do this analysis. And so when I make it a little bit crazier, when I tweak these lines and things a little bit, you can still go back to that same thought process, I think, okay? And so where do we profit maximize? What's the golden rule? Well, we talked about the golden rule, right? It's the tattoo you should not get. MR equals MC, where marginal revenue is equal to marginal cost. We find the quantity. That's all we find. And MR equals MC. We find the quantity at which we profit maximize. Well, the beautiful thing about finding quantity at which you profit maximize is then it becomes the only place on the graph you even need to look, right? It's the only data you need. Why would you produce at a different quantity other than the one in which you profit maximize? It's absolutely no reason, okay? And so we go back here and we find MR equals MC. MR is your blue line, right? Your demand curve also equals marginal revenue. MC, that's this yellow-green check mark right here. They intersect here at point E. It's kind of a three-step process when I analyze a graph like this and when I'm trying to find all the information necessary to figure out where I profit maximize, how much I profit maximize. The first thing I do is I find MR equals MC, which we've done. The next thing I do is I found my quantity, right? MR equals MC, I find my quantity. Then I travel back up to my demand curve as step 2, because I need to know what price I'm getting for my good. Okay, what is my revenue per unit, right? What's my demand curve? What's my price? And I come back up to the demand curve and I see that my price is 5. And then I go find my ATC. Remember, we're just traveling that vertical plane there at 12 units where we profit maximize. So I'm gonna go, in this case, down to my ATC. That's a good sign. My price is greater than my ATC. That's a good thing. My revenue is greater than my cost, okay? I go down, and then I can find my average total cost per unit at 12 units. I now know I get $5 on average per unit, and the cost associated on average is $4 per unit. The difference is $1 per unit in profit. That's how much I'm making. Times 12 units gives me $12 in total profit. That all looks good, right? This rectangle right here, you will see in your homework. So if you get confused about how to place this rectangle in your homework, come back to the slide. It's going to help you out. It helps sort of create a profit area that then you can put your cursor in and you can actually see the calculation for the area. How do we calculate area? Base times height. So 12 times 1 gives me 12. 12 is my total profit. It is basically this area that I've shaded in this rectangle here, okay? It's a very common way to do this analysis is then to put this rectangle in here that reflects the amount of your profit or your loss, as the case may be. And we're going to talk about that here in a minute. Any questions about that? Okay. You've already seen this, right? We already went through this, but let's just do a quick review. In perfect competition, marginal revenue is equal to the market price. Yep, that's the blue line. Price is your demand curve. Marginal revenue is equal to it. Yeah, those are the same, okay? Firms increase production as long as marginal revenue exceeds marginal cost. As long as what you're bringing in for that unit is greater than what you're paying to produce that unit, you should make that unit. You should keep making units, right? And if we go back up to our chart of data here, right? As long as your 5 is greater than whatever's in your marginal cost column, as long as your marginal revenue is greater than your marginal cost, you should continue to produce. On a graph, we look at where they're equal because we go from when marginal cost is lower to marginal cost is higher as being our point of transition from like increasing profits to decreasing profit. So you can see we get to unit 13 here. It costs us more, $6.50 than we get for it, which is the $5. We don't want to make unit number 13. We want to stop. Okay? That's all that's saying. And then we have our golden rule, which is just that. The golden rule doesn't change depending on market structure. It stays the same. So every chapter in which we talk about market structures, I'll tell you the golden rule again, because it holds true for all of them. Okay? All right. So let's switch scenarios here. Let's talk about losses. Not every company gets to earn a profit all the time. And there are going to be scenarios which we look at our data, we look at our graphs, and there aren't any profits, positive profits to be found. Well, that doesn't mean you shouldn't continue to operate. Perhaps you should continue to operate. But it is through this analysis that we will be able to determine that. There are firms that operate under losses all the time. Whether it might be like a seasonal thing, like the ski resort here in Flag, you know, they have fixed costs that they have to pay. And the only way that they can pay those fixed costs, or at least cover some of those fixed costs, is to do things like hold weddings or do their scenic chairlift in the summer, you know, try and scrounge up the money that they can in the interim. But they're probably operating in a loss. Firms do it all the time, and it does make sense to continue to operate under losses, at least in the short run, depending on how your analysis works out, okay? So fixed costs and minimizing losses. Fixed costs is the #1 factor in trying to decide whether you should continue to operate in the short run or not, whether you should continue to experience those losses or not. Depends on how high your fixed costs are and whether you can get any of them covered or not, okay? Firms produce rather than shut down if total revenue exceeds variable cost. So if you're experiencing losses, what is the factor that would determine whether you should just shut down or continue to operate with those losses? Well, it's this thing right here. If you can't even cover those new costs you are incurring by continuing to operate, which are your variable, you need to shut down. But if you can at least cover your variable and maybe some portion of your fixed, you should continue to operate. Because your fixed costs are there no matter what. Even when you produce zero, you still have them. So if you can get any of those covered, your variable plus any portion of your fixed, you should continue to operate in the short run. Short run. I don't know what you should do in the long run. If I ask you that question on an exam, what should this company do in the long run? Your answer is, I don't know. We do not have enough information about any particular company, right, to make that determination, whether they should shut down in the long run or not. But I know that as long as you have those fixed costs, and I know what those fixed costs are in your short run, I can do this analysis for you and I can tell you whether you should continue to operate or not, okay? I'm gonna show you a graph here in a minute that I think will help. The marginal analysis is that per unit analysis, right? That's that bottom graph. Firms produce rather than shut down where the price at least covers your ATC. When that horizontal demand curve in this case, right? Horizontal demand curve at least covers your ABC. You gotta cover those variable costs and some portion of your fixed to justify continue operating in most cases. Questions so far? Okay, I know it's a lot. That's why we're spreading it over 3 lectures, right? Okay. Shutting down in the short run, many firms continue to operate when reporting a loss. If AVC exceeds the price, so if your average variable cost is higher than your price or your AVC curve is higher than your demand curve, at all rates of output or at any quantity, you need to shut down. If you can't even cover variable costs by continuing to operate, you need to shut down. because you're just increasing your losses. You're not decreasing your losses, okay? Fixed costs are sunk. You can't get back the money that you committed to paying on your lease or whatever else. So you just have to pay it, and you have to figure out the smartest way to at least try and pay some of it. Even if you can't pay all of it, you got to try and pay some of it and try and minimize your losses, because in the end, you're going to have to come up with that money anyway, right? Or file bankruptcy or do something else, right? So you might as well minimize. So let's look at what is virtually the same two graphs that we just looked at before, but something's changed. Remember, we are a price taker. The market told us we got $5 per unit. Well, the market's changed. Something shifted. And now we only get a price of $3. This is what your graph would look like if your price per unit determined by the market was now $3 instead of $5. Changes everything, actually, right? Your cost curves are all the same. Cost didn't change because price changed. Cost stayed the same. So all of your cost curves are exactly identical to the ones you previously saw. What's different is your revenue lines, your revenue curves, okay? So you can see up on this top one, right? It's upward sloping, right? Your total revenue, it has a constant slope, but instead of getting $5 per unit, you're only getting $3. So this total revenue line is a lot lower than the one that was achieved at $5 per unit on the previous set of graphs. You can see that there is no point on this graph where your cost dips below your revenue. This is all losses for you, all losses. Your goal when you're experiencing all losses just has to be to try and minimize those losses. So if you were just looking at the graph in order to find that place, this graph of totals here at the top, you would, instead of trying to find the greatest vertical distance when your costs dipped below revenue, you're now trying to find the smallest vertical distance. You're trying to find the place where your revenue and your costs are the closest, which means you're experiencing the smallest losses, okay? That's what we've done here. And we found the shortest vertical distance at 10 units of production. So we profit maximized at a price of $5 at 12 units, but our price has changed. So our price has changed to $3. We can no longer profit maximize. Our goal is loss minimization instead. And we find that here at 10 units, okay? So let's look down at this graph. It looks pretty much the same as the one you saw before, except for instead of your blue demand curve marginal revenue line being at $5, it now sits at 3. Now sits at 3. What else did I add to this? I added a curve. What did I add? I told you we didn't need it for the last one, but that you'd see it later. It's your AVC, right? Your average variable cost curve. Your average variable cost curve becomes a useful piece of information when you're analyzing for losses. Because we know that variable plus fixed gives us total. So we know that your fixed cost is represented by the vertical distance between your AVC and your ATC. We talked about that in the last chapter, right? So when you put your AVC on there, it gives you a little bit of a guide about your fixed costs and whether you're covering any of them or not, okay? So let's look at our situation here. We're still gonna go through that same 3-step process when analyzing like we would for profit maximization. We're still gonna find our MR equals MC. Still a good point for us. It's our best case scenario. And if our best case scenario isn't profit maximization, well, then it's going to be loss minimization. And so no matter what, you're still going to go looking for that point. So MR equals MC happens here at point E. Okay, MC, check mark, MR, the blue line. Thank you for those of you who said ABC. You can see that your price of $3 sits below your AVC. You're not going to cover your costs. You already knew that because we talked about it up here, right? But down here, you can actually visually see that. Well, once I find my MR equals MC and I come down here and find the quantity, I need to go back up and find my price. My price is $3. Then I travel up to my ATC. If I have to travel up from my price or my demand curve to my ATC, I already know I'm in trouble, okay? My cost is greater than my price. But then once I have found those 2 points, the shading for loss is pretty much the same shading. But in this case, my cost is greater than my revenue. So I have a $1 loss per unit. That's the area of this rectangle, times 10 units. That's where I found my MR equals MC at 10 units. 1 times 10 is $10 in loss. We already knew that, right? We already knew that. Can anybody tell me, by looking at this graph, if they think we should continue to operate in the short run?
Would the answer be yes, because our AVC is lower than our fixed cost?
Yes, the answer is yes. Your explanation might be a little off, but your AVC is lower than your price. Yeah. So your fixed cost is represented by the area between this bottom red dot and the top dark red dot. And can you see that we're covering a small portion? We've covered all of our variable. So from 0 to 250, so we have 250 in variable costs. Do you see that? 250 in variable costs, but we're getting $3 as our price. We're covering 50 cents of our fixed costs. So I think you are on the right track, but yeah, we would continue to operate. At least in the short run. I can't tell you about the long run, okay? So our loss is this portion of the fixed cost. We got this lower portion of the fixed cost covered. The fixed cost is, looks like $1.50, right? The difference between $2.50 and $4, the difference between our variable and our total. So our fixed is $1.50 per unit. And so $1.50 per unit, we've covered 50 cents of it. We lose $1 per unit in fixed costs. That makes sense. That all adds up. Any questions? You're just going to have to study these. Just going to have to study them, okay? They don't go away. They just get more complicated. So make sure that you understand. All right, so let's talk about supply curves. We haven't talked about that yet. We talked about a firm demand curve. We talked about all kinds of cost curves. We talked about revenue curves, but at no point did we talk about a firm's supply curve. Well, this is the point at which we can take all of that data, all of those curves, and we can actually use them to determine what our supply curve is. There is a very strong correlation between your marginal cost curve and your supply curve, and you're going to figure that out right now, okay? The short run firm supply curve, so we're talking about for the individual company, okay, to go along with that firm demand curve, which is that perfectly horizontal line in a perfectly competitive market structure. The portion of the firm's marginal cost curve, that's your check mark, that rises above the lowest point on the AVC. That's also the point of intersection, remember, where your MC crosses your AVC, becomes your short run supply curve. I'm going to show you that here in a minute, okay? The industry or market short-run supply curve is simply a sum of all of those individual supply curves. It always is. How do we calculate market supply? Well, we go to each supplier, we figure out what their supply curves are, and we sum up. How much are all of these suppliers willing to give us at $1, then $2, then $3, and $4, et cetera, okay? So this graph right here, let me kind of explain what you're looking at because it looks a little crazy. Here's your marginal cost check mark. Starts down here with these yellow dashed lines. You'll see why they're dashed in a minute. And then continues up. There's your check mark, your MC. Here's your ATC. Here's your AVC. This was the graph you did for me, minus all of these blue horizontal lines. This was your worksheet, okay? All of these blue horizontal lines are possible demand curves, possible prices that we could sell our good at. Here's the interesting thing about being in a perfectly competitive market structure is the price is determined for you. So it's a crapshoot, right? You actually don't know what price you're gonna get, but it's important for you to know what prices work for you, what prices allow you to operate, at least in the short run, hopefully in the long run, and which prices are a no-go for you. There are going to be prices where you just aren't willing to supply any because supplying actually increases losses. So this is just an analysis of 5 different prices and what that means for you as a firm, okay? Your cost curves remain the same no matter what the price is, what the price that you get to charge for your good is, but that price can change depending on the market. And it does, right? Okay. So let's go through these prices. P1 is a price, P2, P3, P4, P5. Demand curve 1, 2, 3, 4, 5. Quantity 1, 2, 3, 4, 5. Okay. Let's start with price 1. Price 1 gives us demand curve 1, which is also a marginal revenue line, right? Demand equals marginal revenue. So if we start by finding MR equals MC, that would happen here at point 1. Imagine this is not dashed yet, okay? You'll see why it is when we go through this. But is that here at point 1? You can see at price 1, when we find our profit maximizing, loss minimizing point of production here at point 1, it doesn't even cover our variable cost. Doesn't even cover it. It lies below variable. If you're getting a price below variable, what that means is that you are actually amassing losses in order to continue to operate. Your losses are growing the more you make. The more you make, the more your loss. Makes no sense. Bad business, okay? You actually would not produce anything at point 1. That's a no-go for you, okay? It actually isn't until we get to P2 or price 2 that you would even consider producing. Guys, this is an important graph, okay? I promise you, you're gonna see this puppy again on Monday. So understanding all these bits and pieces and scenarios is pretty important, okay? Any price below P2 is a no-go. You wouldn't produce for any price below P2 because it is at P2 that we find what is called your shutdown point. It is the point at which you reach that you have to seriously consider whether you're going to shut down or not, and any price below it is a shutdown for you. Now, the thing about P2 or point 2 exactly, you don't have to shut down right here at P2, which is the point of intersection, right, between your AVC and your MC. It's that exact price, wherever that happens at. It's what we call your shutdown point. The fact is, at that point, you're covering all of your variable and none of your fixed. Well, if you shut down, you still have to pay your fixed. If you keep operating, well, you have to pay your fixed. So whether you operate or shut down right here at this exact point, it's the same for you. It's the same. Your loss is your fixed. Why might you make the decision to keep operating at your shutdown point?
If there's hope that the price is going to rise in the future.
Thank you. If you think there is hope that the price might go up soon in the future, you don't want to shut down, get rid of all your employees, have to start up again. No, you want to keep going, right? The other reason you might make the decision to keep operating is to keep people employed. If you're if you're going to have the same loss either way, you might decide you're willing to just keep people employed for the sake of keeping people employed. Okay? At least as long as you can. As long as you're covering the cost of those people, which is your variable cost, maybe just continue to operate just to make sure at least people are going to have a paycheck, at least for the short run, right? Those are the only two reasons I could think of. Okay, so let's go to price 3. Price 3, MR equals MC, happens right here at 0.3. Here's your MC, here's your MR, happens at 0.3. What's your situation here? What's going on? You losing money, you making money? Should you shut down? Should you continue to operate? What should you do? Thoughts? Are you making money or losing money? Go ahead.
It seems like you're covering part of your fixed cost, but not the whole thing.
Great. That's exactly what's happening. It was actually the scenario we just went through on the previous graph, right? You're losing money. You're losing money, yes. But you are covering at least some portion of your fixed cost, right? Your fixed cost is the vertical distance between ABC and ATC. And you're probably, well, not quite halfway in between to covering half of your fixed cost, but maybe you're covering 40%. Yeah, you should continue to operate in the short run. We don't know about the long run. We're not worried about that right now. We're worried about today, right? So you're losing, but you should continue to operate in the short run, okay? So then we get to P4. P4 or 0.4 is where MR equals MC, is what we call your break-even point. That is the price at which when MR equals MC, you are just covering your total costs. It's a break-even. You're not making anything, you're not losing anything, right? So that's gonna happen right here at price 4, demand curve 4, which gives us 0.4, at quantity 4, right? And then if we go to P5 or price 5, we're actually making profit because our price is above our ATC, right? If your price is above your ATC, you're golden and you are experiencing profits. Anything above price 4, you're experiencing profits, okay? So there are a lot of prices in here. There aren't just 5, right? There are hundreds of prices in here, maybe thousands. But this just sort of gives you some important thresholds to make some decision making. Now you can see that your marginal cost line just happens to house all of those MR equals MC points. Points 2, 3, 4, and 5 lie along your MC. So does 0.1, but you're not willing to produce down there. So that's not part of your supply curve. But when you are given a price and then you determine the quantity at which you profit maximize at that price, that's your supply. That is what supply is. Supply is the quantity that suppliers are willing and able to supply at a given price. Well, what you're willing to supply at a given price is the quantity at which you profit maximize. That's what you're willing to supply. Why would you supply any number different than this one, right? Or loss minimize, as the case may be, right? And so we just said in the previous slide, the short run firm supply curve is the portion of the firm's marginal cost curve that rises above the lowest point on the ABC. So this part of the MC that rises above 0.2 and up is actually your short run firm supply curve. You are not willing to supply down here. Is this your part of your MC? Yeah. Your MC is the whole check mark. But your supply curve, your firm supply curve is 0.2 and up, tracing your marginal cost curve. Okay, any questions about that? Okay, let's go through one more slide. And that's this guy right here. This is easy, especially compared to everything else you've done. What this addresses is this thing right down here at the bottom. The short run industry supply curve, the market supply, is the horizontal sum of all the firms' short run supply curves that are in that market, that are in that industry, okay? So let's look at this. Let's say we only have 3 firms in our market. We're just keeping it simple. This is a homework problem you will have, is this one. And I'll kind of tell you how your homework one's going to be a little different than this, but it's the concept, it's the process that matters, okay? Let's say we have 3 firms in our market. In a perfectly competitive market, we would expect supply curves to look pretty similar because costs are usually pretty similar to these firms producing these perfectly identical units of a good, okay? So you can see that we have supplier A, supplier B, and supplier C. Upward sloping like we would expect. This is actually mimicking the supply curve you saw on the previous slide, right? It ends at some point. It ends at the point in which the ABC has its lowest point, right? It's basically your shutdown point is where it ends. And if we are trying to figure out what industry or market supply is, we would simply try and figure out at some given price what each of the firms are going to give us and then sum it up. So at price P, supplier 1 or firm A is going to give me 10. Firm B would give me 10. Firm C would give me 10. All 3 firms at price P would give me 30. 10 plus 10 plus 10. Easy, right? At price P prime, A is going to give me 20. B is going to give me 20. C is going to give me 20, 20 plus 20 plus 20 gives me 60. Those are just then the 2 points along the industry or market supply curve that we would create or expect to see. Easy. Here's how your homework is going to phrase this. Your homework is going to give you one curve, like let's say firm A's curve. And it's going to tell you that all firms in your market have an identical short run firm supply curve. And then it's going to tell you how many firms are in your market. It's going to tell you have 100 or 300 or 50, or it's going to give you some number depending on your version. It's just multiplication. If every firm has a similar firm supply curve and each firm would give you 10 at price P, just multiply it. If one firm is going to give you 10, then how many is 100 firms going to give you at price P, right? Just do the multiplication. 10 times 100, sorry, I know you guys can't see that. Right, just do the multiplication. So at whatever price they give you, take the quantity one firm would give you and multiply it by the number of firms in your market. And then that's how you're going to plot your industry or market supply. Any questions on that? That's where I would like to stop for today. It's a good stopping point. Anybody have any questions? It's a lot, and you're probably not going to understand it the first time you hear me say this stuff, right? All right, is somebody saying something? If you'll just talk a little louder. Good? Okay. You can start working on your homework now. You probably have, 2/3 of what you need to complete your homework. So it might be in your best interest to start plugging through that. Any other questions? Thank you, Skogan, I try. All right, guys, have a good one. Come back on Friday, we'll finish this up. Thanks for coming. Have a good day.